Good morning. What I have for us today is a Sargent Greenleaf 8560 as part of the 8500 series. It is a group UL Group 1R lock, and all the R means and what makes it an 8560 is that these wheels are made out of Darlin plastic type material, and it means that it's impervious to an X-ray type of attack. There's some other interesting features to this lock, and to my knowledge, no one in the lock sport community has been able to crack this lock. And some of the discussion of how to crack this has revolved around an audio attack. And to explain that briefly, and to explain an idea that I had and explored over the last month or so, we're going to look at this lock, particularly how it works and what we might be able to do. So I have the correct combination dialed in, which we can see that all the gates are aligned right underneath the fence. So if I rotate my wheel back to 0, and as I push in on the dial, what that does is that pushes that cam off to the side and starts interacting with this lever spring. So it's going to push the lever spring out. It's going to disengage from where it is, allowing the fence to fall. And if everything is correct, we'll go ahead and fall into those gates, pressing my relocker, and we can rotate the bolt. Now, if the combination is not dialed in correctly, and we go back to our 0, and we press in, we can still actuate it. However, our lever does not fall and ride on the wheel pack. It will fall on, and because of the spring mechanism on the lever, not the lever spring, but the actual spring that's holding the lever, it will only allow the lever to fall if all the gates are aligned. Otherwise, it will strike the wheel pack and come back and strike the casing. So during Group 2 manipulation, we rely on that fence riding along the wheel pack during the entire manipulation, whereas with the fence off that, we can't manipulate this, and this is what makes this lock supposedly manipulation proof. So the idea was, and we have that roller that resets the lever spring, as we can see. So the idea is that possibly via audio, we can listen for that lever striking the pack, coming back, and then possibly hearing a difference. Like I'll line up this gate underneath the fence and go back, and we'll go ahead and actuate that, and theoretically that might be a different pitch or a different frequency than if it was just striking 3 solid wheels. One of the problems that I have come up with over the last month is that when this lever spring falls, it vibrates ever so slightly and adds in a lot of noise into the signal. However, it vibrates at a lower frequency than, or a lower pitch than, the fence actually striking the wheel pack. So what I attempted to do, and what I did over the weekend, is made a very crude amplifier with a second order low pass filter in front of it with variable capacitor, and I was able to filter out a lot of this noise here, and that way when I pushed in and everything fell, all I was able to really hear was a little bit of the motion from the core vertically, or the spindle vertically going up and down through the wheel pack, and then also the strike. So I was able to detect the strike however, very slightly. And I was looking at an oscilloscope at the time, but it was detectable. But I wasn't able to detect enough going around, and this is with the known combination, no less, to be able to decipher something that was really concrete. And a lot of that is most likely because of how crude the circuit was, which if you are truly interested, let me know, and I can provide you a link to the schematic of what I drew up, and it was based off of pieces and parts I had around the house. But it is possibly something there. I also had the pleasure of trying this out on a 8560 that was mounted to a safe, and nothing. And it was mainly because of the quality of the amplifier and the simplicity of the circuit. So if somebody was wanting to do an attack or manipulate this via audio, I think that there is promise there. I think that there is something that can be done, and it is worth pursuing, though the quality of the circuit, using a higher order low-pass filter, better components with tighter tolerances, certainly a better microphone, and being able to have a more sensitive amplifying circuit to be giving you the cleanest signal possible on the output, whether that's something that you're going to put into a computer to be able to do signal analysis that way, or to watch on an oscilloscope or some other method that you can think of. I think there is enough there that you could possibly do manipulation of a Sargent & Greenleaf 8500 series just using audio. So it's not something that I have successfully done. It's probably not something that I'll be able to successfully do for a long time. That's if I continue pursuing that path for the manipulating this type of lock. However, I figure putting the information out there is a good thing, and somebody might be able to take it and run with it and be able to figure out an attack using the audio feedback from this particular lock. So hopefully this finds its way to somebody that has a lot more electronics knowledge than I do, and has a lot more drive to explore this further, and possibly help out somebody that might have had the same idea as well. So I'm putting it out there to the community. As far as I know, this isn't an attack that is well recorded. From what I understand, there's rumors that this can be manipulated through feel, though most locksmiths, including my local locksmith, has admitted that if he came across this, he would use a destructive entry method and then replace the lock. However, here in the Locksport community, we're interested in the non-destructive entry, and this lock in particular is it is a very fascinating lock, and it's something that I would love to see somebody crack. So I'm putting some ideas out there, see if anybody can take them and run with them. Anyways, if you have any questions, please feel free to contact me. If anybody wants to see the embarrassingly simple circuit that I was messing with over the weekend, please let me know. I'd be more than happy to share it with the community. Anyways, I hope everybody has a good day, and take care.